Hello, and welcome back to Talking Transformation, the Appledore Research Podcast. My name is Robert Curran. Talking Transformation is all about shining a spotlight on new thinking in telecom operations. Groundbreaking ideas, technologies that don't just improve telecom, but offer a real step change in agility, performance, customer experience, and the value potential of telecom operators. Our two guests today provide a pretty amazing example of that in the field of using AI to run networks more efficiently. I think that their example has even greater significance than purely functional for reasons that I'll come to shortly. But frankly, if your mind isn't blown by their story, then I'll argue you don't quite understand just how fundamental the AI revolution in telecom really is. And you need to, because it's not just about the technology. You can't have an AI strategy in telecom that's only about models or tooling or even just about data. It's much more important than that. It's about people, mindset, process, and the ambition. I think it's about aiming for 10x, not 10% improvements. For context, our guests today, officially called Team Launch Loop, were the winners of a recent hackathon hosted by AWS ahead of the Fuse event in Dublin run by the Telecom Infra Project, or TIP. So I officially welcome Kevin Collins and Stephen Dillon. Hi, Kevin. Hi, Stephen.
Thanks very much for having us.
Thanks.
I've also asked Francis Haysom, my colleague at Appledore, back to help drill in some of the details on this really fascinating project relevant to his research, digital twins, observability, and imagery. Francis, welcome back.
Thank you for having me back, Robert.
Always good. Guys, let's get right into this. We had an opportunity to meet at Fuse in Dublin. You guys presented, were successful in winning the hackathon competition there. Before we get to that, Stephen, why don't we start with you? Just a bit of background about yourself, where you come from.
Sure. Yeah. So my name is Stephen Dillon. I'm from Dublin. I've been working in telco now for about 15 years. So I started working kind of on the radio optimization side. Kind of started like most people do in the industry, like an apprenticeship from drive testing up to planning, optimization. And 2016, I went back and done a master's in machine learning. So tried to adopt some machine learning algorithms into telco very early. There was some AI conferences around telco at the time, but it was really a kind of a young topic, I would say, in telco at the time. Implemented some live AI systems into SON, for instance, built my own SON system, geolocation systems within one of the operators here in Ireland. So when I left that particular operator, I had billions of data points being generated per day, running through different models. So yeah, a lot of background in this particular area, and I think the new focus on agentic is really something that I'm interested in and trying to bring forward in the telco industry.
Great. We'll certainly spend some time talking about that. Kevin.
Cool. Thanks very much for having me. My name's Kevin Collins. I was working 16 years in the corporate sector, so that's in IT, background in cybersecurity. So 5 years spent in cybersecurity, working up to more senior positions in Huawei, but VHI was my last position. So VHI is Ireland's leading health provider. Last year, last September, I came out into the startup world. So I ran a medtech startup. So I was building electronic health record systems for GPs. And I wasn't getting much traction on that. So it's only 2 months ago, I spun up a new company that's EchoFold. So we do everything AI. So we're currently teaching AI. We build people's startups as well. And we're releasing products now as well. We're going to be releasing a sovereign AI solution very shortly. So I just found that my background in IT, infrastructure, cybersecurity, it just leads into I am now able to pretty much code anything with the new coding tools, and I'm trying to teach that to other people to make them aware of the significance. So it's only in the past 2 months that this is fully possible, that you can now code anything, full stop.
Fascinating, incredible. And just to read something you didn't mention, I don't think you spent 16 years in telecom. Is that correct?
No, it was 16 years in IT, various different sectors. I'm not in the telecoms industry. So this was literally my first introduction to the telecoms industry.
Okay. And that's fascinating. I think as the story unfolds, I think that's something I definitely want people to understand and take away. The combination of your skill sets is quite fascinating. Stephen, maybe we could start with the hackathon and kind of work backwards a little bit. But
Sure.
what was just tell us a bit about the form of that. What was the starting point for that? Were you given a set of problems to work with or a set of data, or where did that process begin?
Yeah, sure. So for the hackathon, there was a number of different streams. We chose to stream around network optimization. So how could we bring agentic AI into how we optimize networks? So this is an area that I have a lot of experience in, and I thought that it would be a great fit for myself and Kevin's skill sets to work together on this. So what we developed, I suppose I'll say what we developed first, and I'll work back a little bit to the data from there. So we developed a 9-agent platform for optimizing RAN networks. So first, starting with the data, what did we start with? So we were given by the event organizers, AWS, a number of different data sources to work with. But I had built in the past things like trace generators. So for instance, what I done for this project is I created a trace generator that generated 1 billion trace records in a specific region of Ireland. So I chose Cork just for no particular reason. I decided to pick Cork. So I created 1 billion customer records, so trace records within Cork. From there, I then took them records and joined them in time and by subscriber. So I correlated them together into 250 million correlated trace events. And from there, I created my 2 data sets that we would then work with. One was a 20 million data set of grid cell data. So that would be 150 by 150 meter grid locations with all of the information around the different cells that serve those particular locations, like for instance, the signal strengths, the quality, the signer, the uplink and downlink throughputs. So that was a 20 million data set. And then I created an even smaller data set of 2,000 records, and that would be the coverage of each cell in the network. So basically, we've done a rapid first step, which was to find specific types of issues in the network that we would pass to the agents. So that was using the 2,000 row data set of geospatial regions of coverage of the cells. So the agents that we fed that to were 4 sub-agents. They were for coverage, interference, PCI duplications, and carrier aggregation imbalances. Okay, so they were the 4 agents we passed this geofence data to. So we would find small geofenced areas or regions with issues. We pass that to the agents. The agents would then talk through an MCP server to the 20 million row data set. So it would query a larger data set, but geofenced in specific regions. That meant that, we were being very efficient with how we used our data. So taking that billion records and using them very efficiently, condensing them down, but keeping as much of that information as possible. So the 4 agents or sub-agents would look for these, would find specific problems and weight them. That would then pass to an assessor agent. The assessor agent would assess the issues. We then had 2 super agents who could supersede some of these issues. For instance, we had an agent for disaster recovery. So if cells off air went over, I think we programmed that at 10%, but it's configurable to whatever the operator would like. That agent can jump in and say, okay, we need to up tilt all of the different cells in the network to restore coverage. We had another agent for enterprise. So the enterprise agent would basically weight the problems in areas where the enterprise customer had locations. So we picked hospitals, for instance. So we want to ensure that if there's issues around hospitals, that their service is restored as quickly as possible. So it would weight those areas higher for problems within them specific regions. So basically, the assessor agent would look at the problems and pass them to a fixer agent. So it would say, how many of these changes can we make? Is there any interference? So kind of like doing some orchestration, passing it to a fixer. The fixer would push the changes to the digital twin. The digital twin would test the changes. If everything was successful, it would then pass to the live network.
Stephen, it's really interesting what you're saying about the agents. One of the challenges we've seen in automation more generally within networks is that it's very easy to automate the process that is already there. It's often very difficult to change the process. How much does the agents you seem to be describing appear to be very different to the way a typical RAN planning and capacity management exercise would work?
Yes.
How did you decide on the agents, and could you give us some sort of context about how different that is from the way people work in the RAN?
Sure, absolutely. I think the problem in telco at the moment, from my experience, I've worked in, for instance, SON for a long time. I developed my own SON products. The issue for me is always around orchestrating changes in the network. We have engineers on one side who are trying to maybe implement features, parameter changes, etc. We're trying to run that at the same time as, for instance, SON algorithms. SON can be DSON, centralized SON. There's no real orchestration over all of these different processes. And what ends up happening is we have lots and lots of conflicts. And of course, each group blame it on the next group. So really, we need, I think, to change the paradigm completely and think, okay, every process that we do should sit within an agent. We need to teach agents to be like engineers. So we have different types of processes. If we think about the telco industry and industries in general now, we won't have engineers that have been in a company for the last 40 years and who understand the network inside out. We need to abstract that knowledge from engineers and move it into specific agentic flows and have all of those agentic flows be managed by a single orchestrator. In my world, that's how this should work. I think the industry needs to take a step back, think about the current processes that we have and how we need to change them, both to fit the technology that's there and also the way people will work going forward. We're not going to have the situation of having people in companies who understand everything end to end for the last 20, 30 years. We may have people in companies for 3 to 5 years. So their job should be to interact with agents who have all of that context.
Kevin, that seems an appropriate point to bring you in at, because obviously Stephen has a lot of domain knowledge in here, but you're coming in from much colder start. Just tell us a bit about how you approach when Stephen comes to you and say, "Hey, I've got this great idea." How do you look at the problem as he describes it, and what's the mindset required to kind of break that into something manageable?
I guess my way of thinking about things with AI is it's completely brand new and it's completely abstract as well. So when I'm thinking about agents, for example, I'm not thinking about specifics. I'm thinking about a job function. So I'm thinking coming at it from a more abstract perspective. So, and then I'm getting AI to figure out the rest. And that might sound a bit bizarre, but so just say we for example, we built the agents for this using with the Claude SDK, with the Anthropic SDK. And then we needed to port this over to Bedrock Strands agents. How do we do that? We just asked AI to just port it over. So when I come at it from this perspective, that's the planning phase. I'm using AI to figure out everything. So I give it a very specific task. This agent needs to do this specific purpose. Tell me the best. Tell me the best. I get it to get AI to figure out the best platform to use. So if we're using LangChain, for example, right, that might be very specific for specific functions, and it might be optimized for specific agents. But to be quite honest, I don't really care. I get AI to figure out the specifics. So I'm abstract at first. Even when we're coming at the hackathon from a planning perspective. So what we done was I didn't even read the requirements. So I passed the the requirements of Claude Code, got it to make out a requirements document, got it to create a plan document from that. Then I got it to create an AWS infrastructure document. And then I got it to create a timeline and like the order of doing things. So, and then I just passed that document to Claude Code and we're like, build. So
Yeah.
from a perspective of how to do things, you just, I'm coming at it from a more abstract perspective, but also from a systems level thinking perspective. So other people coming at this from like an AI assisted DevOps perspective, they would run straight into build this, where I'd be running straight into, okay, let's plan every single little aspect of it. And it's very important to be planning from like a production infrastructure perspective as well, because if you're just say planning to have a backend on just say an EC2 and that's running on Node or whatever, then that might not be optimal if you have to move it then to just say an RDS service then after that. So it's basically, I'm coming at it from a completely new perspective, and this applies to anything. So even yesterday, a guy came to me and he's working in the VR space where he was trying to basically have a chatbot connect to Unreal Engine. I've never worked with Unreal Engine before, but within an hour we had a working chat MCP, and he was able to create assets within Unreal Engine. And I've never worked with Unreal Engine in my life, and within an hour we had that up and running.
Kevin, you've highlighted it's, I think, a very important change for telco. You seem to have completely decoupled what is AI and agent platform and what it does from what is, I would describe as what Stephen is describing as knowledge and data. It seems that decoupling allows you to have a freedom which, so let's be honest, telco systems at the moment are highly coupled in terms of data, knowledge, and process. How important has that been in terms of your success?
You wouldn't believe how crazy, like every single day there's something new that surprises me. Every time I go home to my wife and tell her stories, she doesn't believe what's happening. But the problem is I'm trying to teach this to other people, and I can't. It seems that my experience and the combination of my experience has allowed me to be completely abstracted. And now we're literally building people's startups. So that's where the level that we're at. So it's I can teach it to people, but it doesn't seem to work with them afterwards because they're not they're not thinking along the systems level thinking method. So it's coming at everything with a process. So like I'll give you a really interesting example. So one of my other hobbies is mushroom foraging, right? So there's a mushroom foraging Facebook account called Mushroom Foraging Ireland. There's 17,000 people in there, and people in there have basically just typed into ChatGPT, where can I find mushrooms in Ireland? And then it will come out with very generic responses. So what I took it from the other perspective, okay, you need to identify the trees first. So I got it to identify open data sources of trees and tree types in Ireland. And then I basically, it wasn't ChatGPT, it was other programs. I now have a map of all the trees in Ireland and their year, the year that they were planted. So basically, if I'm in a forest, I don't need to look at the tree. I can look at the map and go, this is planted more than 15 years ago. It's a Sitka spruce tree. I know that was 14 year old. So I'm coming at it from that perspective. And then that's more of a systems level thinking. And now I have 100% chance of finding winter chanterelles because I know exactly where they are, for example.
That's fascinating, Kevin, and I think it's another good example of some of this alternative mindset, a new mindset that's in telecom. As Francis says, telecom is largely driven by process, and here's how we do things, and here are all the things we can't do, and everything has a regularity to it. But now, because of the tooling that's available, we can think in more abstract ways about operational problems, and putting those two things together, you can yield some really important results.
I think that the barrier of entry is completely like lowered. It's nearly as low as it can go. Like in the last 2 months it was basically Claude Code with Opus, the Opus model when that came out a couple of months ago, that literally changed everything. So I tried to do this probably 3 or 4 months ago, and it wasn't possible. So it's literally only become possible to have this level of coding and understanding right now. So and then you combine that with other tools as well, and that's one of the things where I would stand out as well is the knowledge of I use the best AI tool for every specific purpose. So like I have one for presentations, one for image generation, but I have one for every specific use case. And I think that's where people should be coming from again. Because what I found is that if I say, oh, okay, I can do this with AI, somebody goes and tries it themselves, and they would basically, the very first iteration would come out not that great. And then they go, AI is terrible. I'm not using that. Where I would basically figure out the limits of each AI tool that I use and then work around those limits. And I think that knowledge, you only get there by basically just using AI for every single thing. It's like we were talking about podcasts. Like I got to a stage where I made a podcast. The image was AI. It was cleaned up by AI. I used an AI track in the theme music as well. So, but other people just like get to one iteration and just find that it doesn't work for them.
Yeah.
You've got to completely dive into the process. It's not a sort of do it once and bounce back.
It's find the limitations of every single one. So like, we'll take presentations as an example. There's a few really good tools out there. Like the best one out there at the moment currently is called Gamma. Gamma will generate you a pitch deck in probably a minute or a presentation in a minute, and you give it some high level overview. But nothing is 100% at the moment. So I would take that 70, 80%, and then I would manually draw it out in Canva then after that. So like where I would normally be sitting there for probably 2 hours trying to pick out a font, now something sped up the process 60 or 70%. But 2 or 3 months down the line, that's going to be 100%. So like that's the kind of perspective that I come at is finding the quickest way to do anything right now.
Stephen, I'm guessing, in your context, given your telco background, knowledge of operations, I mean, you must have a sense that this kind of technology, this kind of capability, this kind of thinking is opening up all kinds of possibilities. There's an awful lot of work out there. What's your views on that?
Absolutely. And like if I go back, say, 10 years in developing different tools that I developed, it took a long time. It was so slow. It took a long time to learn how to do different processes, how to, for instance, a large data pipeline of maybe a few, maybe 10, 15 billion rows of data a day, just to figure out how to parse it correctly, what tools to use, how it's just so much easier now. Like you can do that same thing that maybe in the past took me 3 or 4 months, I can do now in a couple of days, so the time frame has just totally shrunk. Same for coding. So like up till maybe 3, 4 months ago, I coded absolutely everything from scratch. So I would start maybe with a template from something I'd written before and code from there. Now I use Claude for basically everything, okay? But I have the ability then to go back in and say, okay, Claude will do a really good boilerplate for me.
Sure.
But I can go back in then and see, okay, how can I optimize this code? So for instance, during the hackathon, one of the processes that Claude had wrote for us took about 5-10 minutes to run. But I knew it should only take, less than a couple of seconds maybe. So I rewrote that process and got it down to, I think, around 20, 30 milliseconds, So there are kind of these types of things. Now, I'm sure within, as Kevin said, in a few months, Claude will have probably already figured out that, okay, we can do this a lot faster because it's getting so much input from people. It's just constantly learning, and the rate of how it's learning is exponential. Like you can see it week from week as new models are launched. Like the leap is huge. It's really it's crazy for someone like me because I've had the knowledge, say, in telco for the last 15 years, and now to see that, you know, how useful is that knowledge? Can it be transferred really easy to like an agent? The reality is it can. And the reality is it has to, because as I mentioned earlier, we're just not going to have the knowledge in any industry, because people won't be in the industry for long enough. So people
Mm,
will be jumping from one industry to the next. We see it already. No one's staying in their job for 20, 30 years. It just doesn't happen.
sure.
So we have to take that knowledge and put it somewhere that we can interact with it. So I think in the future it will make it much easier to move from between industries, because the learning curve will be much smaller. But I think that's a good thing. It frees up people's minds to do interesting work. Like if we look at what people do now, if you take strip automation away and you have a pyramid, basically everyone is down at the bottom of that pyramid doing, the grunt work. That's what most people are really doing. Even in engineering jobs, most of the work is kind of grunt work. And what we want to do is just uh, keep using automation to move people up that chain. And then, when people start to get to the top of that pyramid, then just redefine what the pyramid is. Now, I've seen it in telco for years. People don't have time to focus on things that they should focus on. They're stuck
Yeah.
down in the weeds. And that's a big problem. We need to start to move people up that engineering chain. Let AI do the pieces that are easier to do, or it's just processor intense, let's say, or CPU intense. Let AI do that piece, move humans up that chain, and then redefine the paradigm when we get to the top, when AI is doing everything. Just keep redefining what we're doing. I think that's the way to look at this.
Now, I think that's very, very constructive and very helpful. I think there's a lot of concern and fear about AI and so
Yeah.
on. But I think the kind of picture you're painting there is it's entirely uh, uh, it is entirely precedented. And what I mean by that is if you look at not so far where I live, there's an enormous kind of former train manufacturing site. You can go and look at that back in the days when it was employing 20,000 people, and they've got a lot of history about how it used to be all the power used to be kind of belt driven. So they used to have physically, mechanical power distributed throughout this huge campus on belts, incredibly inefficient, but it worked. And I kind of looking at that and some of the things you're talking about there, and thinking, look, that intelligence is kind of like that now, and that now that's not how factories work. Then we went into kind of electric power; it could be distributed in different ways and different technology, and then became people avoided some of the dangerous work involved with moving machinery. And now we have much more distributed intelligence. Use the power of those tools to make the work more meaningful, more enjoyable, and more rewarding and safer among other ways. So I think there is a precedent for this kind of stuff. But it's important to understand this is where we are. We are at this era-defining pivot. I think to the sort of world that you and Kevin are describing, where you can learn things incredibly quickly as long as you understand the right questions to ask and the tools that are available in your toolkit. Don't build from scratch. That's a crazy approach. It may be tempting, and telcos love to build things from scratch, but it's going to lead you down a wrong path for sure.
Yes.
Stephen and Kevin, this sort of nicely leads on to the whole sort of issue of trust, I guess, is that my observation in telco is that we tend to kind of trust humans like they're 100% infallible until they fail, but we kind of have a complete inversion of that when it comes to automation or AI, for example, where we are mistrustful of it, and in many cases that's right. We're all aware of the hallucination factor in AI, for example. How have you dealt with trust in terms of the hackathon, but also how are you seeing that wider story of gaining trust to the kind of decision making that you're enabling?
I've got the perfect example for that, because like my previous startup was literally developing electronic health record systems for GPs, and healthcare is the perfect example of the use of AI and trust. So like a lot of people are like going, we're never going to put AI into healthcare systems because hallucinations and all that. But the fact is that if it's going to be 60, 70%, 80%, is that good enough? Is that more consistent than a doctor? So like we're having these conversations with GPs, and probably the worst time to go to a GP is midday after lunch on a Friday, because GP's sugar might be lower, and their decision making might be dropped. So like I think it's all about risk and people's actual perception of risk. Like if you put AI into analyze all of our biometrics, and it gives out recommendations, and that helps a million people, but one person dies. Okay, so what's the benefit? Like, what's the risk reward on that? It's pretty good, but is that one person dying? I guess it's a question of ethics. But then if you don't put it in, there's a risk of doing nothing as well. So that's what people are not calculating at the moment, the risk of doing nothing. And I think it's not like the biggest thing that I'm learning from this whole AI bubble at the moment is psychology and the willingness to kind of open up and learn. If I'm speaking to kind of traditional developers or even cybersecurity professionals, they're completely against AI. They just don't use it. They don't trust it. And the trust element is interesting as well with the likes of VO3 and all the other video making. Like you have definitely seen videos that have been AI that you have not been able to tell. So, but that's also interesting from a kind of startup perspective. So you have to attach your personal brand to a company now, because nobody trusts the words coming out, because everything is AI generated. So there's going to be a shift more towards real life stuff. That's why I kind of like teaching in person and stuff like that. There's more of a willingness for people to have in-person events.
I'm just going to say on the telco side, just to come to the trust piece, what we tried to do was, well, one of the reasons for the digital twin was to show that, I think for engineers, like if I look at Son, for instance, engineers had a huge distrust of Son because it was scripts running to the OSS making changes. They didn't really know what the changes were doing. They had some understanding, but it wasn't visual. And what we tried to create in the hackathon was to have on the right-hand side of the screen a digital twin, on the left-hand side the live network. And what we were doing here was to show the engineers that what you see update on the right-hand side of the screen would be transferred to the left-hand side of the screen when those changes were implemented. And for me, I think as Kevin was saying, from a psychological point of view, people distrust this type of technology. But I think if the engineers can visually see something change on a digital twin and then be passed from there to the live network, and they see the same thing happening on the live network, then I think that really instills that trust within them. And that's, for me, what was missing in the past on the automation side in telco. I think it needs to be really visual for engineers to really say, okay, we get it, we understand it, and we trust it. And I think one of the major pieces that we had, I think it is a little bit of a breakthrough that we came up with this kind of digital twin and live network. I haven't seen it before, and I think for me, as an engineer, it just makes total sense to me.
You were using a digital twin. You were using a digital twin that those engineers were familiar with or already used, or was that that wasn't something developed?
It was something that we developed. Yeah. So basically, the digital twin was, so we took the data from the network. We could see that on the left hand side of the map. On the right hand side, we had the same data set, but updated with the changes that we made in the network. So for instance, let's say we down tilted 10 cells, up tilted 15 cells, changed the power on X number of cells, or whatever parameter changes we made. We reflected that within the digital twin. So this is the next state where your network will get to when we make these changes. So basically, we tested the changes first in the digital twin with the assessor agent. The assessor agent would look at how has the network improved compared to our last state. And if it was positive, it would then pass those changes to the live network.
In terms of, can we just talk about that stack a little further, just to be clear what because my understanding is that what you've built is not just a kind of demonstrator, a mock-up. You've built something that, in principle, could be put into production tomorrow. Just talk to us about what's in what you've built, and then what's outside of that in terms of going into a production environment. What would actually be required to take those things and put them into a live network? Do you see what I mean?
Yeah, so I suppose if we look at the stack, so we developed everything on AWS, and in a lot of the networks that I've worked in over the past 5 or 6 years, we see, a large move towards the hyperscalers. And some companies, of course, want to keep things on-prem or on their own cloud platforms. That's fine. We try to keep the architecture as, let's say, as transferable as possible between hyperscaler, bare metal, etc. I think the pieces that let's say, to bring what we've developed now to a production platform, what would we have to change? Well, in terms of data input, we have the parsers that we need, for instance, for trace data, PM data, CM data. And the way that I want to develop this was that it would have a very low barrier to entry, okay? What do we want when we go into networks? We want as much data as we can get from them, okay? We want trace data. Why? Because it's customer level. But a lot of networks that you go to will say, we don't produce trace. It's too expensive for us to produce or to store. So I didn't develop this as part of the hackathon, but I've developed in the past and have it available, is PM parsers that will distribute the traffic similar to what you see on the trace side. So there's two ways to do this. You can either take a couple of hours of trace data and train that against the PM data. If you don't have any trace data, then the probabilistic piece becomes, let's say, it becomes more probabilistic, but it still has a nice fit to the data, because from the PM, for instance, we get the timing advance. We know the angle of the antenna, the bearing. We know the opening angles of the antennas. If we bring in the population density coverage maps, we can probabilistically start to distribute the traffic, not only in distance from cell, but also in angle from cell, okay? So all of that can be probabilistically distributed. For the KPIs as well, we can distribute them based on the overlap of additional cells. So for instance, let's take something like drop calls, for instance. If we have two cells that overlap in, let's say, 30% of their coverage region, and both cells have very high drop call rate, and we see additional cells overlapping with those particular cells that have lower drop call rates, then probabilistically it's more likely that those problems are happening where those cells are overlapping. Okay, so you can start to distribute your KPIs based on a model that's being built in the back. And this is very important because telcos, they don't want to spend lots of money on these solutions. And for me, that was the problem in the past, was that anything geolocation related had to include trace data. Of course, it's better to include trace data, but it doesn't need to be a necessity. And actually, the system that I developed can start with just cell GIS data, okay, and use lots of different prediction models to predict how far the cells should cover based on the height of the antenna, the power, et cetera, Okay, so you can start from a really, really low let's say a high resolution like GIS data, and go down to that low granular data like trace. So it's being able to bring something in and into an operator really easily, and then scale it up from there, because over time you want to build in more intelligence, but basically you want to be able to create this cell grid data layer with as little data as possible. And then as the networks become more and more, let's say they have more and more trust in your tool, that they start to give you more and more data and spend more money. I think it's very hard to get these systems in from the start where they require huge data sets. You want a low barrier of entry and then scale from there. So that's the way we try to design the platform. I hope that makes sense.
Yeah, I know that makes sense. And again, it's reflecting something that we're picking up in a lot of our conversations. I think the mood is away from the sort of big bang, hey, let's solve all this in one go, and more towards the sort of approach you're describing, much more step by step. Start with something, localized, good scale. By all means, have the vision for where you want to go. But in turn, bringing that between the questions of trust that Francis was talking about, let's build up the trust in areas we can manage, rather than trying to kind of change everything in one go. One of the things I'm conscious about is whether, I mean, in terms of what you developed in the hackathon, what did you get any feedback either from that event or even from discussions afterwards about the potential return on this for an operator? I know this was just the scope of this was by your choice, across a single county in Ireland essentially, but is this a millions of dollars of problem, a $10 million or a hundreds of million? What's the rough order of magnitude, Stephen, that you would put on this?
Yeah, it's potentially it's enormous. Okay, it's really enormous. And I spoke to a number of operators at Fuse, and they seen the value, and they see the need to move to agentic workflows, because they know that they're not going to have the same level of engineers in the future. So they see this as a reality that they're going to have to breach very soon, or they're going to have to bridge very soon. They see that they need something like this within their network. Really, it can be in the hundreds of millions in reality, because what can these types of tools do? They can come in, they can start low key, they can scale very quickly. And once the orchestration is in place correctly, it's very easy to build agents on top. So all we need is to understand the use case. Okay, so let's say, for instance, I mean, we built 9 agents here, but I have another 50 agents I could build within, a couple of months, no problem. For instance, take power saving. Okay, you can easily build an agent to look at power saving, for instance. Okay, that can be built in very quickly. We can look at mobility traffic versus stationary traffic. How do we model mobility traffic, indoor, outdoor scenarios? How do we improve coverage for indoor? So I have another algorithm that can figure out which traffic is indoor, which traffic is outdoor, what the difference is between indoor and outdoor traffic, and where we need to change specific parameter sets on cells for indoor traffic. So they're just a couple of examples, but of course this scales out massively, and every operator has their own set of problems. In the past, I think the issue was that we tried to build a solution for each of these different problems that the operator had. It needs to be as modular as possible, and it needs to be very easy to integrate each module into the overall platform. So once the orchestration is done correctly, that for me, the two most important pieces for me is the data, ensuring that we're using the right sufficient amount of data, not too much data, not too little data that gives us the correct amount of insights for the agents to be able to make their decisions, but not so much data that it's inefficient in terms of costs. And on the other side, that the orchestration is done correctly so that it's easy to add additional modules in. So specific problems that specific operators have, we can easily integrate those types of modules in.
Stephen, you make a key point there, that it's the orchestration is your flexibility. All customers are different, but your ability to effectively orchestrate a set of actors in a way that deals with the customer's problem is the key learning here, as opposed to a kind of, I'm just looking at this very specific task here. Is if you're operating everything, you're not only improving the individual task, but you're also creating a kind of wave of secondary effects in terms of the ROI. I know that we do quite a lot of ROIs for companies, and it's really interesting. You think the effect is changing somebody in the NOx performance, but actually there's a tidal wave of effects that go into customer care, experience, etc., even into capex procurement, that can be brought by this orchestrational effect of bringing together information.
Yeah, absolutely, completely agree. As I said, there's so many downstream effects to these things. Like you change one specific scenario, but the downstream effects can be massive on top of that. Like for instance, churn reduction is something that I've done lots of models to model it in the past. How do we model this correctly? How do we predict churn? But the reality is, if we have a suite of agents who are optimizing the network constantly, then it's a natural, it's a natural effect that churn will be reduced. I mean, it's just a natural downstream effect. I think enterprise as well is another kind of focus area for me with 5G. Like most of the use cases are more industrial, and how do we get the most out of those types of use cases, so how can we ensure, like the healthcare, for instance, for hospitals, how do we ensure that any issue that happens which is geo-fenced around a hospital is immediately dealt with? So we need mechanisms there that can trigger really quickly to take over the normal orchestration to say, okay, we have an emergency here, this needs to be fixed immediately. I think there's a lot of different pieces that kind of fit into this puzzle. You have your overall orchestrator, and then you have super agents which can sit over that to say, okay, we can take control of the orchestration now. But that has to be managed very well. I mean, for me, this is the difficult piece, is the orchestration. But again, I think things have become so much easier in that space now. It's not like it was 10 years ago where we had X number of features and so on, and we had these really complex matrices of how each feature reacts with other features. Now it in the end it's kind of like weight driven, but it's abstracted from us in some sense. It's taken care of by the model itself. It's abstracted from us, and that abstraction is a good thing, because it's too difficult for us to understand the underlying the underlying algorithms, like the neural nets that are looking after this kind of weighting. So it needs to be abstracted from us. We need to have the intent on what we want the algorithm to do, but the algorithm can take care of that under the hood.
Guys, we're nearly out of our time here. There's a couple of questions I'd just like to explore for the last few minutes here. Kevin, appreciating this was your first your first exposure in the wild to a bunch of telecom people. I wonder what you took away from this experience about some of the ways in which the problem set was talked about, people thought about the issues or the non-issues. What would be your advice to the telecom industry at large in thinking about this kind of technology and area?
Well, the first thing that comes to mind is that it seems to be the absolute perfect application of agentic AI. So, like, if we're talking about other kind of more restricted areas, like when you're dealing with AI, and like when you have something that's black and white, like, is the network bad? Yes, okay, fix it. It's just so simple, and you have so many data points as well. So, like, agents are best at automation, for example, and making those decisions really quick. So when you need to make a billion decisions, it just makes total sense. But the barrier of entry seems incredibly high. So most of the students that were taking part in the hackathon, and like even myself, like I've worked in IT for years, but I've never had any exposure to the telecoms industry. I think that the barrier of entry into the industry seems pretty high. So the students were very they're very open-minded, because they're like, cool, this is a whole new industry, but I don't see anyone kind of going, hey, come on in. It's just, I don't know. It seems a bit, the barrier of entry. It's like other industries, like cyber. I'm not like singling out telecom, like cybersecurity is pretty high barrier of entry as well. So, but the thing that I came away with is I didn't realize the significance of what we built. So after the hackathon, I was just like, cool, we won, amazing, like I'm really happy. And then we went into that conference, and then speaking on stage about the potential of building what we just built, and then it just started to sink in. And other people looking at this, they might just go, "Oh, you've just built something with agents in it to optimize a network. That's not that difficult." The secret sauce is what the knowledge that Stephen put into this. So his algorithms that got that timing down to milliseconds. And I just can't take it lightly enough. It's just I when we were start getting invited to speak to like heads of various companies, I was just kind of, my heart sunk a bit because I realized what we'd built. And it's crazy that I think this should be just for anybody listening, more of a incentive, or just go and do it, because we literally built this in 2 days. Again, there was a lot of planning that went into it, but I think it's just to open up people's minds, as in change that perspective and just think that anything is possible right now, in terms of building. And I prove that every day. So just go figure it out. Make your plans bigger, try and figure out how to actually implement them. And it's possible right now. And if anybody wants to walk through, just give me a shout, because I'm really open to sharing my knowledge in building. So
That's great. That's great. And Stephen, from your point of view, what's next here? I mean, great to win the competition, but having worked in a startup myself, the idea of being on stage with the vice president of AWS and the CTO for AT&T, that would have just been like a crazy idea. So I totally get where you're coming from. But congratulations on getting that. But what's next for you here?
Yeah. So, first, I'd just like to say, I think Kevin, his way of thinking is brilliant, and it's changed my way of thinking as well. So I have a number of different products, both in RAN and fiber networks, that I'm looking to productize now. So I'm kind of working towards that. I have a number of systems that I've set up, and that I've tested in a number of different networks as well. So on the fiber side, I've tested in a few networks, with really, really, really positive results. Again, taking tasks that are generally either not done very well by the industry or are done by external companies manually, like geospatial analysis. I've automated that completely, and kind of trying to wrap that around the company at the moment. On the RAN side, this is my kind of bread and butter for a long time. So I do really want to build something now, a real production system, an agentic production system. I don't think we're far off getting there. So myself and Kevin were doing some work on this yesterday, but I think I can have a really production ready system done by early next year, with many, many more agents than are in the platform now. I'm working back over some of my old code as well, but basically what I want to create is a platform where I have data feeds that I can generate on the fly and inject problems into the network, just to show it working to operators. So I have a lot of that already built, but I just need to structure it correctly now, bring everything in. But of course, with Claude Code now, it's so much easier to say, take a piece of code I've written in the past and say, okay, I want to build this functionality into this system, and something that in the past would have taken me maybe a week or two to integrate that fully in, I can do now in a couple of hours. So the time frames have really, really shrunk, so something that I may have been planning to release maybe towards the end of next year, I'm now thinking of, okay, I can plan and release this in Q1 2026. So that's my plan. We'll see what happens. I have a number of different meetings set up with different operators over the next few weeks. So let's see where it goes. But I'm gonna push on with this. I think the industry needs some change, and hopefully I could bring part to that change.
Yeah. Well, I think that's pretty much assured for both of you guys. Kevin, if you want to stay working in telecom, I'm sure there's a bright future for you here. There's plenty of need out there.
You're welcome in with open arms, Stephanie.
Gentlemen,
Thanks.
congratulations again, and thanks so much for your time today and sharing your story with us, and also online. Appreciate it. That's the job of Talking Telecom, is to try to showcase things that are happening that are different and interesting, and whatever part of the industry come from, startups, giant companies. We're all open to people with something interesting to share. So thank you very much for your time today. Thanks, guys.
Thanks, Robert.
Thanks so much for having
Francis.
us.
Thank
Cheers.
Thank you.
you.